If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in GATE-EM theory series. So today again we will be solving 5 questions starting from question number 46 up to question number 50. Okay, then let's try to solve these questions. Okay student, if you come to question number 46, an electromagnetic field is radiated from. So this is a very basic concept. So if you have a point charge, if you have a stationary electric charge, then you will have only electrostatic field. So I will write it down for you so that you remember this one. A stationary charge will indicate only electrostatic field. So if you keep a charge, there will be electric field around it, that is electrostatic field. If you have a steady current, that is a constant current flowing, then you will have only magnetostatic field. And if you have a time varying current, then you will have electromagnetic effect field, both electromagnetic field, EM field, electromagnetic field. So you need to have that's why the electromagnetic field is radiated. So you need a time varying current. So if it's stationary point charge, it will not give, a capacitor will not give a current with a DC current, conductor carrying DC current, that is steady current, this will not give. A oscillating dipole means it will be continuously changing its polarity. So it will be, the current will be time varying, it will depend on what polarity it is at what time. So dipole, it will be continuously changing, so it will give a alternate feeling, or that is a time varying current feeling. Now if you come to 47, the electron with velocity v is placed in electric field E, the magnetic field B, the force accident field. Again, you know, if it is a placed in electric field, then it is Q into E, and if it is a placed in magnetic field, then it is Q into V cross B. So Q is here electric field, electron, so it is minus E charge you can place, so it is minus E. If you take common, then it is E plus V cross B. This also you can give as a this one. So this is your option D. This was also option D. So if you come to now 48, the two conductors are carrying forward and return current I and minus I as shown in the figure. The magnetic field intensity H at the point P. So you want to find this magnetic field intensity. So this Y is, so you can think of Y is in this direction they have given. So if you come to P, you can consider this one. If current is going that, one current will be going down. So you can consider any one. Suppose positive is going this, negative is going down. Okay, so if I take this current is coming out, or this current is coming down, whichever way. So if I take this is coming out, so this is the direction. So P will get a magnetic field around this. So there will be a magnetic field in this direction because I am taking this current. So this direction, so you can consider P at P, the direction is this. Now due to this, because this current is this, so this current will be this. It is returning. So it is returning, so here magnetic field will be my, these 4 fingers you can see in this direction. It will be moving in this direction. This is my field, so it will move in this direction. So this is the field, so it will move in this direction. So if you come here at P, here also you will get in same direction. So both these will be added together. So it will be either plus Y or minus Y, because they have given only Y. This is the Y direction you can see. This is X direction and this is your Z direction. So this is your Y. So obviously you will get in Y direction. So you can consider it plus Y, minus Y, whatever, because they have given, not specified which direction it is. Because you can consider this plus coming, this minus down, or this minus down, this plus coming. In whichever way, one can come and throw one, it will come, and throw one, it will return. So if I consider due to this one, due to this I, so what is the formula? It is I by 2 pi into R. R is here D. And that vector is, suppose I am taking positive Y, this is Y. Plus, then due to this one, that I by, don't put there minus I, because we have already considered the direction and the sign. So you take only absolute value, and that direction or vector you consider by using right hand thumb rule, which direction it will flow. So we have seen that both these will be added. So it will be, if you add it, 2 will get cancelled, that is I by pi D. That is your option A. The two infinite strips of width W meter, width is W meter, and it is infinite strip, it is in X and Y, in X direction as shown in the figure. Suppose this is X, this is Y, and this is my Z. So this is placed infinite strip, but the width is X. They are separated by a distance of X. One is carrying positive plus I, one is carrying minus pi minus I. The inductance per unit length of the configuration is measured to be L. This is measured to be L. Okay. and the distance of the separation between the strips is reduced to x by 2, the inductance per unit length. Now the most resemblance to this one, if you can recall your power system, inductor of two single phase conductor, what is the inductance of a single phase conductor, what was the formula? But that was circular conductor. We have considered that is ln d by r dash. You remember this one? This was the standard formula for inductance of a single phase wire, where current is going through this I and it is returning through this I. But they were circular. What is the total inductance? So that is the best resemblance, but here it is not circular shape. But one thing you can feel, if d is increasing, then L is also increase. If d is the decreasing, then this is also decreasing. So if this distance is decreasing, then you can feel that you can see anywhere outside here magnetic field due to this and magnetic field due to this will be getting reduced. So you can feel it here. If d is increased, it is directly proportional type. D is increased, then L is increased. D is decreased, L is decreased. But here ln is there because it was a circular shape. Here that will not come. That is, in this case it is directly proportional. That means it is reduced. That we have seen. So if it is x by 2, then the inductance will be obviously reduced. That is actually in this case, if you derive it, don't need to derive, it is be half. So it is directly proportional. So if it is, inductance will get reduced by half. That is option C. The best resemblance is this one. If you know the derivation of this one, then you can feel that it is also half. We will see this one in power system, and we will start power system after EM theory. The inductance along the solenoid length this much wound uniformly over 3000 turns on a cylindrical paper tube of this much diameter is. So inductance, you know, this is the formula mu 0 n square A by L. We have used this formula earlier. Mu 0 is 4 pi into 10 to the power minus 7. N is 3000 square. And what is its area? Area is 60 mm diameter. So it will be pi r square. 60 by 2. Mm means 10 to the power minus 3 pi r square divided by L. Length is given 100,000 mm. So 1000 into 10 to the power minus 3. So if you do this one, you will get 31.97 millihenry. That is approximately 32 millihenry, which is your option C. If you like the video, then press the like button and please give your valuable comments in the comment section.